Trolley game is a game of chance that involves a spinning wheel and a ball. So you throw the ball into the wheel, not really throw it, but you, you spin the ball around the wheel, and eventually it'll land in a slot. All right, and the slot corresponds to a value on the table where the wagers take place. All right. For now, or at least for this example, I'm going to start off with something very, very basic. All right. So, values on the wheel are arranged on the board where the scoring takes place. The values span from 1 to 36, half of which are red and the other half are black. In addition, there are two green values, 0 and 00. I'll be more specific when we actually get into the activity. We want the expected value for an outcome of red in the trolley game. And the scoring odds for this event are 1 to 1. All right. So what we're looking at here, let me just get my pen going. So we have red. Oof, this is brutal. This is the price I pay when I forget my Apple Pencil. And apparently my spare Apple Pencil. Yeah, it's definitely not in there. So there's 18 out of 38 that are red. All right. And that's because there's Apple Pencil. Ooh. Appreciate it. Okay. Connect. Connected now. Does this have the plug-in? No, so it's I got to do it a different way, right? How do I do it with this one?
I put it on the top of the iPad and it will not connect.
Oh, okay. Let's see. Hopefully my iPad isn't too old. So far, no good. Yeah, I have the old school one where you plug it into the port. Yeah, it's not going to do it. Thank you anyway, though. So close. Yeah, my school issued iPad is an older generation. So 18 are red, 18 are black, and 3 are green. All right. So that means that there's a total of 38 possible outcomes, 18 of which are red. All right. So this is the probability of getting a red. All right. What I want to know is what the expected value would be in the long run for playing this game and betting on red. All right. So the possibilities are that we could win or we could lose. If we win, now it says compute the expected value for outcome of red in the trolley game. The scoring odds for this are 1 to 1. So that means whatever I wager, I'm either going to win that amount or I'm going to lose that amount. So I'll keep it simple and just go with $1 or 1 credit. But we often talk about money in expected value, so it kind of makes sense. So if I win, I'm going to win $1. If I lose, I'm going to lose $1. The probability of success, the probability of winning, 18 out of 38. Probability of losing would be every other possible outcome that you could have. All right? So 18 out of the 38 will get you a win. The 20 that are left over out of the 38 will cause you to lose. So for expected value, and I know it's been a week, you multiply the amount that you would win if you stand to win, if it turns out that you win, you multiply that by the probability of winning. And you do the same thing for losing. All right. So that's going to give me 18 out of 38. 1 times 8, 1 times anything is anything. All right. -1 times 20 out of 38 will be -20 over 38. Add these values together, and you're adding a negative, so you're really subtracting, and you'll get -2 out of 38. Now, since we are talking about money here, just kind of look at this as a weighted average. All right. So this is the expected amount of money that you would stand to win if you actually won. All right. So I'm just going to go to my calculator here, type in 2 out of 38. It's about 5 cents. All right. So in the long run, you stand to lose $0.05 per dollar wager. All right, wager, bet, same thing. All right. Now that doesn't sound like a terrible thing, especially in comparison to the lottery question that we did last time. Right? In the lottery question, we determined an expected value of 50 cents, right? Half a dollar. So in the long run, you stand to lose. If you bet $1 in a lottery and you play that lottery over and over and over again, and you take all of your winnings and all of the losses, add them up and divide by the number of trials, you should get about 0.5, right? Negative 0.5. In the case of roulette, if you take all those outcomes that you get over time, average them together, so you win $1 here, you lose $1 there, you play the game, let's say 500 times. In the long run, you should end up behind by 5 cents, right? Which kind of makes it seem a little bit more advantageous to play the trolley game or roulette than it would be to play the lottery, right? But the thing is, in the case of casinos, well, a couple things. One, the likelihood that you're betting just $1 is very, very low. All right, very small probability. And that's because most tables have a minimum bet, right? There's some of them where you can't even play unless you put down like $20 per spin of the wheel. All right. Now, if you win, you could win a lot, but you could very easily go through, let's say, $1,000. Right? So it'd be just 50 spins of the wheel, and you could be down $1,000. All right. 50 days of playing the lottery at $1 a day, you'd be down $50. All right. So it's a risk reward situation, but and you might think in terms of the casino, for the casino perspective, why would they ever do this? Why would they give you a chance to play a game where the expected value puts it at very slightly not in your favor? And the answer to that is 5 cents may not mean a lot to you, right? And on an individual level, you know, if you were the only person to go to the casino, they get 5 cents out of you, right? They're like, okay, so that was a waste. But if 20,000 people go through the casino every day over a period of a year, those 5 cents start adding up, right? And also, this is a target number. This is what it all should kind of work out to be. But like I said, if you play the lottery for 50 days, you're only down $50, right? Now, $50 is, it's not what it was back in the 80s, but it's still a fair amount of money. I don't think it, like if you took a $50 bill out of your wallet and put it on the table and then looked away and it was gone, you're probably not going to be happy. But you're going to be less upset about that than if you had a stack of 20 of those $50 bills on the table and somebody walked away with it. All right. So the lottery, yeah, it's not to your advantage to play. It's less favorable than it would be for, in comparison to the game of roulette or trolley game as we're calling it. But the potential for you to lose a ton of money quickly is not there with the lottery. All right. And in fact, if you went into a deli, wherever they sell lottery tickets, stationery store, you go in there and you say, I want $1,000 worth of lottery tickets. They're going to tell you to leave. They're like, I'm not printing out 1,000 lottery tickets. So it's very hard to lose a lot of money quickly with a lottery. In the case of roulette, the minimum bet, let's say the minimum bet is $1. That's the minimum bet. I mean, you could potentially put $500 down per spin of the wheel, right? And I think I mentioned this at one point. If not, I apologize. The gambler's ruin strategy, which is you play, you lose. Okay, so I lost $20. So now I'm going to bet $20 more in order to make up for that value on the next turn, on the next spin of the wheel. And then you keep doing that, but you don't have unlimited resources. So if you don't eventually hit, then you're broke, you bust, and the casino wins. And that could all happen in the span of like 5 minutes. Right? Now, what I do is I study the wheel. In the casino they have a display that puts all the previous outcomes. So I'm not really looking at the wheel. I'm just looking at the big board. So it'll say that, let's say, black came up the last seven out of the last 8 spins of the wheel. So black has been coming up pretty frequently. In order for the probabilities to balance out, red would have to happen at some point. So you just kind of use your best judgment of when you want to get in, but at that point you throw a few bucks down on red because you figure it's due, and then you hit and you just walk away. All right. So that's a little bit of the background, but I have a sheet here that I'm going to talk to you about. And, where did I put mine? Oh, because I put mine in the wrong packet. So actually, I'm going to stop. So mathematically perfect. All right. So payoff odds, I'll get into that in a minute. But we want to be thinking about, all right, if I'm going to place a wager in the game of trolley or roulette, there's a few different ways that I could do it. If I just put, like, let's say in that video I just showed you, let's say that was my wager. I just put like $100 down on 2 black, or just 2 because 2 is black. It's a black outcome. Then I would have gotten 35-1 as a payout, right? So if I take whatever my wager is and multiply it by the payout odds, that'll tell me how much money I would have got. All right. So I would get $3,500. That $100 bet, I get that back also. It's not like the lottery where you lose the dollar. You get the new money plus the old money. So I'd walk away with $3,600. All right, which would be really nice. But then it begs the question, who's got $100 to just put it down on a number and hope that it comes up? I mean, the likelihood of hitting that is 1 in 38, right? So on average, out of every 38 spins, you could expect the number 2 to come up once. So if I were to bet $100 every single time for 38 trials, the best I could hope for is to be down 300 bucks. All right. And that's, well, the best I could hope for is that I hit it on the first trial. But if we assume, and this is not guaranteed, but if we assume that it's like clockwork, that every outcome is accounted for in every 38 spins, it is possible that the 2 black comes up on the 38th spin. So I would have already lost $3,700. Then I would hit, so I'd be down 200 bucks. All right. So, and not a good strategy to just kind of hope for the best. All right. So there's other types of bets. You have a split bet that pays at 17 to 1, roughly half of what you would get if you wagered on one value. A 3-number bet, they call it a street. That pays at 11 to 1. 4-number bet, also called a corner, and I'll show you why it's called that in a minute. That's 8 to 1. 6-number bet pays 5 to 1. Outside dozen or column pays at 2 to 1, and then outside or even credit bets pay 1 to 1. And be careful. And I'm not saying that you should get on a bus to Atlantic City after this class, but I can tell you that if you're going to go and try to play this game, you got to be aware of what the table rules are, right? Because that minimum bet, that usually applies to the outside and the inside. And when I say outside, I'm talking about anything. Let me get a nice bright color here. I'm going to go with this one, make it thick. All right, so anything on the main board is considered a wager on the inside. All right, anything outside. Oh, sorry. This also counts. I was just shocked that I was able to write legibly with this stylus. That all of this is the inside. All right. The outside is all this stuff here. So all of this over here. Oh. This is going to be like my growling video. All right. So this would be considered outside. And so would this. All right. I know it's not as visible. I'll label it up better when I can actually write legibly. All right. But when they say that there's a minimum bet, it's usually a separate minimum bet for the outside as opposed to the inside. So if it's a $10 minimum bet, you can't split it between inside and outside, right? So you couldn't do like $5 over here and $5 over there. It would have to all be accounted for inside the main body of the table. And if you wanted to bet something on the outside, you'd have to reach the minimum for that also. All right. So that makes it a little trickier. And that's one of the modifications I make for this activity. We're going to assume that the minimum bet applies for any combination of wagers. All right. So what we're going to do is we're going to invent a strategy. All right. I've already done one on the back. It's not as easy to make out as I would like because the whole color document but printed on black and white. It's not pretty, but it gets the job done. And I also have the online version. All right. So this is a kind of a guided example, but I'm going to take you through one separately. All right. So I'm just going to pretend that none of this happened. I just wanted to have something in print for you to look at. All right. So this is that, and you can have a look, but I'm going to take you through. Now, this is the worksheet that you're going to get, but since I'm using this as an example, I didn't want to give you the sheet and have you copy down all my work and find that you have nowhere to do your own work. So I'm going to take you through this. Actually, I'll duplicate the page just so you get a good look at what I'm asking you to do. Copy. I just get a second page in there just so I have it. Oh, lordy. So the first thing you're going to do is develop a betting strategy for wagering 10 credits, dollars, whatever you want to think, on a single spin of the wheel. You may not wager all 10 credits on a single outcome, right? So what you're going to have to split your wager up. So I'm going to show you a strategy, and then you'll come up with your own strategy following this approach. The random number generator, that's a little bit of a kind of a trickier thing. For that, you want to get technology involved. Otherwise you'd have to go out and buy a spinner and spin it, and it would take forever. All right, but I'll show you how to handle that on, let's say NumWorks. But I'll say NumWorks for now, but I reserve the right to switch over to Google Sheets. All right, so again, just going back to the different possibilities. I could bet on a single number. I can bet on a pair of values. I can bet on a street, a corner, 6-number bet. I can go outside. I can stay inside. All right, so let me show you an example. Come on. It's supposed to be like a 2-finger scroll, and it's not responding the way I want it to. All right, so I will do, let me just bring my board in here. I'm going to do a corner bet here. So if you bet on the corner, you're taking your chips, whatever denomination of chips that you have, and you put it on the corner between 4 adjacent cells, I guess we'll call it. All right. So I'm going to do that, but I'm also going to do a 6-number bet over here. All right, so the 6-number bet, if I put it on this little baseline here, if I put the chip on the corner between 2 adjacent values, what it's going to do, that's like code for I want anything that falls in this set of outcomes. All right. And actually, let me make this one, red's not going to work. I'll make it a bright green. So these would be my winning outcomes. And you notice I have a little overlap there. All right? If you create an overlap, then, well, you'll really kind of hit the jackpot if you win. All right? But we wouldn't necessarily know that going in. So, we're here to learn about probability, but also apply it in a meaningful way. All right. So I'm gonna I'll do 5 and 5. $5 down, or 5 credits down on the corner 16, 17, 19, and 20. All right. So let me thin out my pen. Go 0.75, that ought to do it. All right, so I'm gonna do $5. I'm gonna just say dollars from now on, it's easier. On the corner, and that's again 16, 17, 19, and 20. But I have it marked up on the diagram, so you don't have to make a note of that if you can make it clear enough. Otherwise, I would say little squiggly bracket, poor quality squiggle, not getting better. 16, 17, 19, 20. And let me just move that over real quick. And then I'm also going to do $5 on the 6-number bet. And that's 19 through 24. All right. right? So 19 through 24. Now, the payout odds are really important because that's going to tell me how much I would win if I won. All right. So for the corner, that pays at 8 to 1. Right. And again, you're not expected to have this memorized. I've just done this so often that I know. 8 to 1 for a corner bet, 5 to 1 for a 6-number bet. All right. I just opted to do these two events, but I could have done pretty much anything on this list. All right. The only thing is I have to have two separate wagers because one of the rules was that I couldn't put it all down on one outcome. All right. So I split it up a little bit. But then this is where it gets interesting. I now have to figure out what I would win if I landed on these values. All right. So for the 5-number bet, I'm sorry, the $5 corner bet, that pays at, I'm just going to move this a little bit. That pays at 8 to 1. All right. The 8 multiplied by the 5 would give me $40. All right. But we have to be careful because if I hit the number 19 or the number 20, I'm also winning the 6-number bet. All right. So if it's only the 16 or 17, then the payout would be $40. All right. Now, another layer to this. If I win one bet, it's possible that I lost the other. All right. So I have $40. Let's say for example the numbers 16 and 17 come up. I'll just keep it like that for a minute. All right. So the number 16 and 17. What would happen is I'd get $40 for winning the corner. All right, just like I said here, but winning this bet means that I lost this bet. All right, so getting a 16 or 17, that's one of the outcomes for the corner, but it's not one of the outcomes for the 6-number bet. So I would subtract off $5. So my payout for hitting the numbers 16 and 17 would be $35. All right, winning one means that I would have lost the other. Now, under normal circumstances, for a 6-number bet, it pays at 5 to 1. Multiply. If it were just a $5 bet, not $10, but just a $5 bet, and any number from 19 to 24 comes up, then I would win $25. All right. But then we run into the issue. Oh, sorry. If I move funny, then my back becomes a problem. And I just tweaked it. I'm actually going to write all the numbers from 19 to 24. 20, 1, 2, 3. Come on. 24. I'm just going to smidge that over a little bit. Oh, come on. Smidged it too far. A smidge too far. All right, so there's no way, for example, if 16 or 17 comes up that I would win the 6-number bet. But if 19 and 20 come up, then I would win actually both of them.
This might be getting to it, but I was looking at the possibilities chart on here. So I noticed that like if you bet on red and 7, it's like it feels like betting on red is sort of like covering your ass. Almost.
Yeah.
Is that sort of like what people do when they're
Yeah, they hedge.
Okay.
Yeah, exactly.
Flat, like a small bet to like cover in case.
Yeah. So you could there might be instances where you win but you don't win any money.
Yeah.
But you don't lose any money, so it keeps you in the game.
Yeah, because I noticed it kind of evens it out because it's like 35 to 1 on one bet, but that's 1 to 1, so like you have more chance of getting 1 to 1 than not though.
Exactly. That's exactly the thinking. You come into a game like this, like you don't want to throw a ton of money away. If you could, even if it means like small losses, like $1 or $2 that you're losing, as opposed to losing $10 at a clip, it keeps you in the game longer. And by doing that, if you have a string of losses, eventually that's going to be balanced out by some wins, right? So you just kind of like holding your head above water until you hit the big one. So I'm just going to focus on the 21 through 24. Those are instances where I will have won the 6 number bet, but lost the corner bet. All right. So if the numbers 21 through 24 come in, I would win my $25 bet. I'm sorry, my $5 bet, leading me to gain $25. But I will have lost the corner bet, so I'd knock off 5 from there, and that would leave me with only $20. Now, only in comparison, it's really not that bad, right? If you think, okay, well, if I win, I'm only going to win $20 as opposed to 25. That's probably you're probably being a little too hard on yourself. Let's just put it that way. But then we have the overlap. The overlap is a beautiful thing because it's kind of like, you think of it as like the jackpot. All right, this is what you're biding your time to see if you can get. All right, so the overlap would be 19 and 20. The numbers 19 and 20. If they come in, then you're going to get $40 from your corner bet, and you're going to get $25 from your 6-number bet, and you're not going to have to give up any money, right? Because you will have won both of your wagers, right? So that would be 40 plus 25, which would be 65. All right, so you would walk away with $65 plus your original wager. All right, your original wager of $10 split between the corner and 6-number bet. So you would walk away with $75 for a $10 wager. All right, now you might look at that and say, well, that's modest. What about that big $3,500 we were talking about before? Well, it's a 1 in 38 chance. I don't know if I want to do that too many times. But what I'll do is I'll play this strategy for a little while. I generally end up ahead, maybe not by a whole heck of a lot, but what I'll do is I'll take the difference between what I started with and what I have now and use that as my playing money, put aside the money I brought with me so that I know that even if I go bust down the line, I still have the money that I had with me, right? So I will not lose, right? So then I'll play the strategy with the new money, and then down the line I'll pick a moment where not only will I bet the corner and the 6-number bet, but I'll put $20 down on 20. So I'll take a shot. It's kind of like in a football game. It's like every now and then you take a chance and throw a 50-yard bomb down the field. Right? You never know. You connect, you get a touchdown, and you're feeling good about things. Right? That's this. Right? Now, if I lose, it is possible that I lose both of them. So anything else, really stray marks here. If anything else comes in, it means I lost. So I'm minus $10. Oh boy. I promise I'm never going to forget my Apple Pencil again. I'll probably forget like handouts and stuff. You know, I try to keep it like, you know, diverse. You know, don't forget the same stuff every time. You know, spread it out a little bit. Forgot my iPad last time. This time I forgot my Apple Pencil. Next time I'll forget the handouts, and after that I'll forget everything, like my entire backpack. You know, just kind of keep it interesting, keep it fresh. All right. So these are our payouts, and indirectly we also figured out the probabilities that go along with each of those. All right. When I said if you get 16 or 17, that's 2 outcomes. All right. If I get 21 to 24, that's 4 outcomes out of 38. So I have my probabilities. I'm going to skip down to number 3. I'll show you the simulation in a minute, but we want to make sure that we verify that this is computed correctly, because the expected value should be the same no matter what your wager is. Right? So if you put $10 down on the number 8, or if you put $10 down on red, whatever, the expected value should always be the same. Right? 5 cents, negative 5 cents if you bet $1, negative 50, roughly 50 cents if you bet $10. Right? 10 times the 5 cents. Right? So my table of outcomes, well, we have different ways to win, so it's not just a matter like we did before of just saying win or lose. We could win in 3 different ways, or we could lose. All right? So I'm going to look at the outcome of getting 16 or 17, the outcome of getting 21 to 24, the outcome of getting 19 or 20, and the outcome of getting something else. So I'll just write else. All right. So each one of these has an X value. The X value is the amount of money that you'll win if you win. It's your take-home pay. All right. So for the 16, 17, we said it's going to be $35. 20 for the 21 to 24. 65, that's the jackpot. Negative 10 if none of those values come in. The probabilities, so we say P of X. Oof. So P of X, well, 16 or 17 amounts to 2 of the outcomes that you could get out of the 38. All right, so it's a 2 out of 38 probability. Boy. 21 to 24 amounts to 4 out of the 38 possibilities. 19 and 20, 2 out of the 38. Denominator is always going to be 38. All right. Because if you count from 1 to 36, and then you include the 0 and the double 0, that's 38 outcomes. Now, there's European roulette, and then every other kind of roulette. And the European roulette only has 0, not a double 0. All right, so there would be only 37 possible outcomes. If you find a roulette wheel that doesn't have a double 0, and you plan on playing roulette, that's the one that you want. All right. Same idea for blackjack. If you're to play that game, there's single deck blackjack, and then there's 2 deck blackjack. The single deck is where it's at because the probabilities are more manageable. All right. If you see 3 aces on the table, you know that there's only one left. All right. It's harder to keep track of all the other possibilities if there's 2 decks. All right. So this is a total of 8 ways to win. All right. And that's how this whole thing balances out. 2, 4, and 2 gives me a total of 8, which means that there's 30 ways that I can not win. 30 out of 38. Right? So you might say, well, there's 3 different ways. I could win with a 16, 17. That'll give me $35. 21 and 24. That'll give me $20. $65 if I get 19 and 20. They're like, oh, this is great. I'm going to win a lot. I'll only lose 10 if I lose. Yeah, but there's 30 ways that you could lose. All right? So that's the balancing act. So x times p of x, 70 over 38, 80 over 38, 130 over 38, and negative 300 over 38. All right. So that's going to amount to negative 20 over 38. All right. This is for a $10 wager. This is what you want to see, right? This means that you did everything right in terms of the computations. Your payouts are correct. Your probabilities are correct. If the expected value ends up being negative 20 over 38, then you did everything correctly. All right. Now, you might say, well, we got negative 2 over 38 before. Why is it negative 20 over 38? We only wagered $1 before. Here we're wagering $10. So what I would do is take that negative 20 over 38 and divide it by the wager of $10. That's going to give me negative 2 over 38, which is about negative 5 cents. So negative 0.05 per $1 wager. All right. It was negative 20 over 38 per $10 wager. So negative 50 cents per $10, negative 5 cents per $1. All right. This tells me that all my numbers are correct. It also tells me, and if you believe what I said before, that the expected value, no matter what your strategy is always going to be the same. It tells me that in the long run, it doesn't matter what strategy I use. If I have unlimited money, I got unlimited resources, and I can afford to play it for 1,000 spins, yeah, it would come out to be about negative 5 cents. All right, but we don't have unlimited resources. Maybe we can only play, let's say 10 spins at $10, 20 spins. I always have 200 is the magic number for me. I don't gamble very often. Very, very rarely now. It's a matter of perspective. Wife, kids. It's like I got to start saving this money, right? As opposed to young single bachelor, and it's like, oh, I got a few extra bucks. I'll go to the casino. So it's all the life-changing stuff. But if I'm going there with $200, $10 a spin, I can play 20 times. All right, 20 spins at a minimum before I'm bust and I have to get out of there. All right. But if I win anywhere along the lines, that gets me more spins. All right. Kind of like the New York Mets. In the beginning of the season, they always win like 10 out of their first 15 games. So I'm like, all right, we're doing okay. Or like one year they went 11-1, right? So that means that they'd have to lose 10 more games before they're 500, before they have equal wins and losses. So that buys me more enjoyment out of the season before the Mets collapse. Because it usually happens mid-August. This year it was like mid-September. So that longer winning streak in the beginning of the season bought me a little bit of September to enjoy the Mets before, they do what they always do. If they can get out to like a 40-game lead, then, might make it all the way to the World Series before we lose. So, Mets fan. I balance it with being a Giants fan, so that's good. Rangers and Knicks. Fortunately, they're doing very well right now, both teams. But they're kind of more in the neighborhood of the Mets. So I got to have the Giants to balance all that awful negativity out. All right. So I don't have an idea of whether this is a good strategy or not. All right. So I can't answer this part of the question because my expected value should be the same no matter what strategy I use. So I know in the long term what's going to happen. I want to now figure out what's going to happen in the short term. All right. So we use a random number generator, whether you use an online generator or you use it on the calculator, which for us is pretty much online anyway. Either way, I just need a number generator to give me the outcomes that I would get if I were to play this game. All right. So the way I set it up is with a random integer. So rand int. I'm going to say from -1 to 36. All right, those are our important values. The -1 is a weird one because if you go from on a number line, -1, integers -1 to 36, it would be -1, 0, 1, 2, skip a few, 36. All right, what I'm doing here is I'm letting that -1, that's my double zero. I don't know why I put quotes around it. That's the double zero. Because, like, if I ask the calculator to give me an integer, it's not going to return a 0, 0. It's just going to get, if 0, 0 comes up, it's just going to return it as a 0. All right? 0 will be the 0. So you look at the table here. I got a 0, 1, 2, 3, all the way up to 36. I just needed something to represent the double zero. All right, so we're going to let -1 be the double zero. So now I just need to do this 100 times. All right, and so that's where technology comes into play. So there's two ways to handle it. I'll show you both ways. The first way is to use NumWorks, or a TI calculator will do it too, but I have the NumWorks up on the screen. So that's going to be, if I'm in my calculation menu, I'm just going to detail all the steps here. Calculate, shun. All right, calculation. Then we go to the toolbox. Talked about this last time, but again, it's last time, so. Unless I'm still thinking of the wrong course. Go to probability. Yeah, we've been in a probability menu in this class. So probability. Random. And then select the rand int A to B. All right, so when you select that, you put in the -1 and the 36. And then hit OK or execute. And it'll bring back a value. I'm really just going tallies here. All right, I want to know how many times I get a number between -1 and 36. That's one of my special numbers. All right. So what I'm going to do here, because I did it as a I did the whole spreadsheet and everything. It looked kind of cool. But for the sake of not going too crazy with this, I mean, 100 outcomes is going to take a while anyway. We have 16 to 17, 21 to 24, 19 to 20, and everything else. All right, I'm just going to use tally marks. All right, so I'm going to look at this and say, okay, 25 is not one of the values, so that goes under else. Hit OK. 20 is one of the good values. 5, not good. 30, not good. You should expect a lot of not goods here. 8, not good. 18, just barely not good. 3, not good. 5, not good. So notice in the short term here, I've spun the wheel 9 times, and I've lost 8 out of the 9 times. All right. So the one that I got, the 19 to 20, that was one of the special values. That would have got me $65 plus my wager, which is great. But I've lost $80. So I'm still in the red. 22, no good. 10, no good. And like after a bunch of trials, I mean, we're gonna do 100. I got to do 89 more. But you saw how quickly the first 11 went. It's showing me that I'm gonna be down a lot of money early on. All right. 7, no good. 30, no good. No good. No good. No good. Still no good. Another no good. That happens more times than you would realize. And actually, that's a strategy I use. If I bet, because I like I said, I like to strategically bet on a single value. Sometimes I'll do that. Like 8 is a good number for me in my experience. So 8 comes up, I'll let it ride for another spin. Because every now and then it happens. Like if I put $10 down, I just got $3,500. By the way, that's never happened. I would leave that money down for another spin, right? Because that's all found money at that point. 17 is a win. 15, no good. 36, no good. 8 is my number. 13, 29, 9, all no good. 4, no good. 20, that's a win. 28, no good. 14, no good. 21 is a win. Something else to keep in mind: the way the values are placed around the wheel. Right? Because consecutive numbers on the board are not consecutive on the wheel. Consecutive numbers are opposite each other on the wheel. Right? So I'll show you real quick. If I have a 1 here, there's the 2 over there. So you could do a split bet between 1 and 2. They're adjacent to each other on the board, but the probabilities, even though there's still 2 outcomes, they're not adjacent. They're not adjacent on the wheel. If you could find adjacent values on the wheel, that's a good indicator of kind of a reasonable strategy. Like 7 and 11, for example. If I look at 7 and 11, they're in the same corner. Right? So they're adjacent to each other on the wheel, but they're in the same corner, so that might be a good approach to take. Right? Things to think about. It doesn't really apply in this activity, but it could be something to consider when you do this on your own. Let's see. 5, 10, 15, 20, 25, 31. Okay, almost there. Not really. 35. 0, the dreaded 0, or double 0. Those are only dreaded when you're betting on red or black. It's like, all right, it's do or die. The last 5 spins were black. I'm putting $100 down on red, and green comes up. Not many worse feelings. All right, so we're on a little streak here, a little winning streak. Yeah, followed by a loss. Got another win, another loss, another win. This is why we do it for many trials, because it is possible that you lose your first 10 spins, but you have a reasonable probability. You know, you think about it, like if you spin the wheel 100 times, you could have a winning streak, like 4 or 5 spins that lead to wins. But if it's 97, 98, 99, and 100, you might be out of money by then. But if it's the first 4 spins, you might walk away and never wager another dollar. All right. 24 is a win. 2 is a loss. 30 is a loss. 10 loss. 28 loss. 34 loss. 0 loss. -1 hasn't come up yet. 26 loss. So that double 0 hasn't happened. 2 is a loss. 21 is a win. 15 is a loss. 17 is a win. 8's, well, if I were playing, it would be a win, but it's a loss. 4. 19 is a win. 7 is a loss. 3 is a loss. Another 7 for a loss. 4 is a loss. 35 is a loss. 33. 21 is a win. 16 is a win. 9 is a loss. 6 is a loss. 40, 50, 65. So I got 35 more to go. Loss. Win. Barely a loss. Win. Loss. Loss. 20 is a win. First double 0. 2 is a loss. 25 is a loss. Just a big loser up here. Loss. Loss. I haven't seen a 1 yet. That's the first one. 36 is a loss. That 8, see that 8 keeps coming up. I don't know why. It's just something magical about it. I got another double 0 there. That's a loss. 28's a loss. 27 a loss. 22's a win. 14's a loss. 3's a loss. Loss. 18 barely a loss. 31. 14. 25. Another 14. A 3. A 10. Twice. See, it happens. Loss. 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 20, 40, 60, 80, 95. I think I just need one more. For the win. Nope. Loss. All right, so I'm just going to double check. 5, 10, 15, 20, 80, 95, 6. Yep, 100 trials. And, you know, spinning a wheel 100 times would have taken a lot longer than that. That's like a good couple of hours at the casino. But you could run through a simulation fairly quickly with just little tally marks. Now I just want to see how much I would have won. As it appears, I probably am not going to have won much. If 16 or 17 comes up, I get $35. That happens 6 times. So that's $210 for that outcome. 20 to 24, I get $20 a pop. That happened 8 times. That's $1.60. My grand prize, not so grand, only 5 outcomes, or 5 times that it happened. 65. 325. All right. Now, $10 a spin for 100 spins. That's 1,000 total wagered dollars, right? Of my own money. But some of it would not have been like money that was physically in my pocket. Some of it is money that I won that I just risked. All right. So keep that in mind. But we have 81 times that we lost $10. All right, so that's negative 810. All right, so 210 plus 160 plus 325 minus 81, or 810, I should say. I said minus 810. I don't know why it doesn't automatically put the answer in there. Negative $115. All right. Now for me, I would still be in the game. All right. So there were, there's 100 spins of the wheel at $10 a pop. I wagered $1,000. But not all of that was money that I brought with me. Like I said before, I bring $200 with me. I have not lost my $200 yet. Right? So I'm still in the game, or at least from my personal strategy perspective. Now, if I take this number and divide it by 100, so I'm at an expected loss of $1.15. All right. So if you divide by the number of spins, so negative 115 divided by 100, that's the number of spins. I'm at negative 1.15 per spin. All right. So my personal expected value is negative $1.15. It should eventually amount to, what did I say, 5 cents. All right. Now, each spin is valued at $10. So really, it's in the neighborhood. It's like negative 11 cents per spin, or per dollar wagered. All right. Which is twice what the expected value should be. But in the short term, there's going to be a lot of fluctuation. In the long term, it should settle in on whatever the value is supposed to be. Now, the last part is really up to you. Like, based off of your calculations, do you feel like this is a good strategy to use? So me personally, I would say yes. Because if I only intend to wager $200, I'm still in the game. All right. Your explanation could be completely different. I mean, maybe you don't want to lose anything. It's not a good strategy. Why? Because I have a negative number. Negative 115, unacceptable. I only accept 0 or positive numbers. You know, you could look at it that way. It's like, I don't want to lose a dime. My follow-up to that would be, so why are you at a casino? Like, if you're afraid to lose your money, then you don't wager your money. Like, don't go to the casino. All right, so maybe you're in a social situation where, all your friends are going to the casino and they're doing it. It's like one in Rome. I mean, that's a different story, but always go in with a plan, right? And stick to the plan. Otherwise, you're playing with fire. And by fire, I mean your future happiness.